In this video, class 11, we are going to start a new thing, okay, which is called multiplication of vectors. All right. Now, before we proceed with the topic, okay, my suggestion is work out the problems that I've already given based on addition of vectors, of course. Okay, you have to be an expert in addition of vectors. Remember that. All right, be it addition of vectors or subtraction of vectors, it's one and the same thing. All right, so you have to be an expert in that. All right, if you have your textbook, you can check your textbook for different numericals based on addition of vectors also. Now, if you have any problems, problem in understanding addition of vectors or in solving while solving some of the problems, okay, then you can. This is my email ID over here that you're seeing. It reads dpn02 dot, there's a dot over here, dra@gmail.com. Okay, so you can write to me here. All right, so let us proceed with multiplication of vectors. So after addition of vectors, we are going to learn multiplication of vectors. Okay, don't worry, we don't have a division of vector over here. Okay, so multiplication of vectors can be done in two ways. The first method or first way of multiplying vectors is called dot product, okay, or scalar product. All right, now why is this called a dot product? Because you literally have a dot in here. Okay, so this dot a, do you read this as vector a dot vector b or a dot b? Okay, so you're multiplying two vectors over here. Now multiplying, when I say multiplying, speaking in terms of vectors, multiplying would be a very general term. Okay, because multiplication can be done in two ways, either dot product or something called a cross product, as you can see. So these notations have specific meanings, remember, particular meanings, dot and cross. Okay, you don't read this as into. Okay, this is not a into b or something like that. Okay, that you do while multiplying scalars or while you do multiplication in algebra. Okay, so this is, you read this specifically as a dot b, remember, and this is a cross b. This is not a into b. And of course, it doesn't have the same meaning like the kind of multiplication that you do in your algebra. Okay, now when we find the dot product of two vectors a dot b, what you get is the product. Okay, the product that you get when you find the dot product of two vectors is a scalar. You have to understand this clearly. What you get, so we are multiplying two vectors, okay, all right, and you're getting a scalar. That is possible only when you find the dot product, remember that. So a dot b gives you a scalar. Now scalars only have magnitude, and the magnitude of that scalar quantity will be modulus of a modulus of b cos theta, or simply ab cos theta, where theta of course is the angle between the two vectors. Okay, now actually this is not something new. You've already seen this being done. Okay, you've seen the dot product of two vectors, and you've seen that in work done. When you studied work done in class 10, work done was what? F s cos theta, where F was the force acting, S was the displacement, and theta was the angle between the force and the displacement. Okay, recollect what you've studied in class 10. All right, so work done is a scalar quantity, remember. And force is a vector, displacement is a vector. Theta is the angle between the force and the displacement. So you've already dealt actually with dot product of two vectors. Okay, so you're multiplying two vectors and you're getting a scalar quantity. So this very thing can also be written as work, which is a scalar quantity, so therefore no vector notation. So work is F dot S. So force dot displacement, remember that. Okay, so this is an example of dot product. Now let us talk about, and don't forget this, a dot b will always give you ab cos theta. This is magnitude of a, magnitude of b cos theta. Now talking about cross product or vector product, as you can see in the name itself, okay, the product of the cross product rather of two vectors, or could be more than two vectors, is always a vector, remember that. Okay, so here I have shown for two vectors. So a cross b will give us a b sine theta. This thing happens to be the magnitude part of the vector. Okay, so this only talks about the magnitude. This only is the magnitude of the vector, remember. So whenever you find the cross product of two vectors, we always get a vector whose magnitude is this, where theta, of course, is the angle between the two vectors. Okay, so I have specified here also the vector, the product is a vector, remember that. Okay, now an example is something that you've done in class 10 also, you've heard about it in class 10 also, which is a torque. Okay, now what is a torque? Torque is something called moment of a couple. And what is a couple? Couple is two equal and opposite forces not acting along the same straight line, of course, okay, which rotates a body is called a couple. Okay, so two equal and opposite forces not acting along the same straight line and which rotates a body is what is called a couple. And the moment of a couple is what is called torque. Now, what is this moment of a couple? Moment of a couple is the product of any one of the forces, and the perpendicular distance between them is what is called moment of a couple or torque. As you can see in this picture, D is the separation between the two forces, okay, but D is not the perpendicular distance between the two forces. What is the perpendicular distance? It is specified by this dotted lines, broken lines. Okay, so this is the direction of force F. All right, this is the direction of force F, and this makes an angle of 90 degrees. This is the direction of the opposite force F, okay, and it makes an angle of 90 degrees. So therefore, this happens to be the perpendicular distance between the two forces, and its magnitude is d sine theta. How do we get this? Okay, since d is displacement, okay, so displacement has a direction, and say for example the direction is this. The direction of displacement is this, and say for example the angle between F and D is theta. So this being a vertically opposite angle, so this is also theta. Okay, now in one of the videos, the previous videos, I had shown you that in a right angle triangle, look at this right angle triangle. Okay, we know the length of one of the sides, which is D. We know one of the angles. Okay, of course this being 90 degrees. Okay, we know the other angle theta. Okay, so we can always find the length of any of the other sides. So this happens to be d sine theta. This will be d cos theta, of course. Okay, so since d sine theta is the perpendicular distance, therefore torque is F d sine theta. Now, if we are to write this in vector form, vectorially, okay, or in vector notation, so it will be this. So tau by the way is a Greek letter, tau, tau, okay, which represents torque, remember. Okay, like we have alpha, beta, theta, okay, which are Greek letters, omega, okay, we also have tau. So tau represents torque. So torque, as you can see, is a vector, is F cross D. Remember that, vector F cross vector D. Okay, so this is an example of cross product, the cross product of two vectors, okay, giving us a vector. And don't forget, in case of dot product, when you find the dot product of two vectors, you always get a scalar quantity. All right, okay. So far we spoke about only the magnitude of the product vector. Okay, and get one thing very, very clearly. A is a vector, some vector, a certain vector. Okay, B is another vector. All right, B is another vector. A cross B is a completely new vector. Remember that. A cross B is a completely new vector, like you can see over here. Say for example this is vector A and this is vector B. All right, the angle between them being theta. Okay, so A is one vector, B is another vector. A cross B is altogether a new vector. Okay, like F cross D is altogether a new vector, which is torque. All right, so when you find the cross product of two vectors, we are going to get altogether a new vector. Remember that. Okay, which has its own magnitude, which has its own direction. So the magnitude of the new vector is of course given by this AB sine theta. Okay, now in order to get the direction, what we need to do is we need to take the help of something called a right-handed screw. Now what is this right-handed screw? Right-handed screw, you all must have seen screws. Okay, I don't know how many of you have worked with screws. All right, so we have a right-handed screw. Now what happens in case of right-handed screw is I rotate that right-handed screw in the clockwise direction like this, in the clockwise direction, the right-handed screw will go in. Okay, I rotate the right-handed screw in the anti-clockwise direction. What happens is the right-handed screw comes out. That is what happens in case of a right-handed screw. Okay, now this cover, the cover of any water bottle that we use, okay, the cover of water bottles also works in the principle of a right-handed screw. Okay, of course, I cannot make this bottle stand over here and show you. Okay, so you have to see this view only. So I rotate the cover of the bottle in the anti-clockwise sense, it comes out or it opens up. Okay, I rotate the cover of the bottle in the clockwise sense. Okay, what happens is it gets tightened up or it goes in. Anti-clockwise comes out. Okay, clockwise it goes in. Okay, so the cover of any water bottle works in the principle of a right-handed screw. All right, likewise this pen that I'm holding. Okay, I rotate it in the anti-clockwise sense, it comes out, it opens up. Okay, I rotate it in the clockwise sense, it goes in or gets tightened. Okay, so this is also working in the principle of a right-handed screw, remember. So when we need to find the direction of the cross product of two vectors, we take the help of a right-handed screw, and this is by agreement, this is by convention, okay, how to find the directions. And what we do is, since it is A cross B, so this is your A, this is your B, we rotate our right-handed screw from A to B like this. So we rotate it from A to B since it is A to B. So this, say for example, this is my right-handed screw, I rotate it from A to B, which means I am rotating it in the anti-clockwise sense. Okay, so what happens to the right-handed screw? It comes out. All right, so the direction of the product, the cross product of A cross B, okay, the direction of this vector A cross B will be perpendicular to the plane of the paper. Okay, perpendicular to the plane of the paper, coming outwards. It could have been perpendicular to the plane of the paper but going inwards, remember. Okay, those are completely two different directions. Here the direction that we are getting, that of A cross B, is perpendicularly coming outward. So the direction of A cross B will be perpendicular to the plane of the paper, coming outward like this, coming outward. That would be the direction, remember. Okay, and its magnitude of course is this. All right, if the question was to find B cross A, sorry, I've written B cross B. If the question was to find B cross A, then you'd rotate it, the right-handed screw from B to A, remember. You'd rotate the right-handed screw from B to A, in which case your right-handed screw would go in. So the direction of B cross A will be perpendicular to the plane of the paper, of course, but going inward. Okay, so you can see the direction of A cross B and B cross A are different. This is perpendicularly coming out, this perpendicularly going in. Okay, and if we see their magnitudes, the magnitudes of both of these vectors will be A, B sine theta. Okay, this would be B, A sine theta, but this BA sine theta and AB sine theta are one and the same. So A cross B and B cross A, they have the same magnitudes, but they have different directions. Okay, therefore remember, A cross B and B cross A are not the same. Only their magnitudes are same, but these two are not the same vectors because they have opposite directions. Okay, what we can rather write is A cross B is minus of B cross A. They are negative vectors. This is what we can write. Okay, because they have the same magnitude, but they have different directions. Okay, so this is about the magnitude and direction of A cross B. And this is how we find the cross product or the vector product of two or more vectors. Now let me also quickly show you the properties of cross product and dot product. The one on the left hand side is for dot product, and the one on the right hand side is for the cross product. Okay, this is the commutative property. A dot B and B dot A are one and the same thing. Okay, because A dot B will have, both are scalars of course, will have magnitude AB sine theta, AB cos theta. Okay, and B dot A will also give you the same thing. So therefore, dot product is commutative in nature. All right, whereas I have shown you earlier in the video itself that A cross B and B cross A are not the same thing. Although they have the same magnitude, okay, they have different directions, opposite directions to be more precise. Okay, so therefore A cross B and B cross A are not the same. Okay, what is true is this: A cross B is minus of B cross A. So remember, the cross product of two vectors is not commutative in nature. All right, now this is the distributive property. This thing is called distributive property. A dot B plus C. Okay, all right, we can be written as A dot B plus A dot C. You can check this, verify this. Likewise, so dot product is distributive in nature. Likewise, cross product is also distributive in nature. A cross B plus C can be is the same as A cross B plus A cross C, like you do in algebra. And this is called associative property. A dot B dot C. Okay, so first we want to find the dot product of A dot B and the dot product of this and the dot product of this C with C. Okay, so this and this are one and the same thing. You can prove that. All right, so this is also associative. Cross product is also associative. A cross B cross C is the same as A cross B cross C. You can check this, you can verify this yourself. Okay, out of these laws, commutative law is very, very important, remember. Okay, because dot product, as you can see, is commutative in nature, whereas cross product is not commutative in nature.